Okay, this video is meant to be notes on how to use conversion factors specifically with moles and molar mass. So, a reminder. Conversion factors work like so. I have a number like 3, I'm going to multiply by 5 over 5, and I should get 3. If I do 3 and I multiply by 127 over 127, I should get 3. We have a pattern going on where anytime I multiply by a fraction, if the top and bottom of the fraction are equal, then my final value will be the same as my initial value. In other words, I am not changing how big this original measurement was, as long as I multiply it by a fraction where the top and bottom are equal. Now, this is not so interesting with just raw numbers like we have here, but it's much more useful when we're talking about using this type of method to change units. For instance, I'm about, what am I about? 5'9". Did I get that backwards? What is that? That's 60 plus 9. So I'm about, let's make it an even 5'10". I'm about 70 inches tall. But if I were to go over to Europe and they asked me how tall I was and I told them 70 inches, they would look at me weird because Europeans measure themselves in centimeters. And it would not be intuitive for them, the 70 inches. It might be, depending on where they were raised, but let's just make this for the sake of argument here. I would need to know my height in centimeters if I wanted to tell them, hey, I'm this tall, and for them to understand me. So I can convert that value. Now what I'm going to do is multiply. Okay, I'm going to multiply by a fraction. I'll put my little fraction line right there. And I'm going to say, I need to know how many inches are in a centimeter. So I'm going to ask Siri, how many inches in a centimeter? And Siri tells me that 1 inch equals 2.54 centimeters. That's important. All right? So if I do this calculation, if I were to take 70 inches, I've kind of painted myself in a corner here. Let me erase this and put it down here. I want to convert my 70 inches into centimeters. I could do this. Here's my multiply. I'm going to multiply by a fraction. And I'm going to say there are two ways. I could either do 70 inches times 1 inch over 2.54 centimeters, or I could do this, 70 inches times 2.54 centimeters over 1 inch. And because in both of those cases the top and the bottom were equal, right? Because 1 inch was equal to 2.54 centimeters. So in both cases the top and bottom of my fraction are equal, so I am not changing my initial value, my 70 inches. I'm just manipulating it. Okay? This should work. But only one of those conversion factors will actually give me a useful answer, and it has to do with the units. So here, let me circle the units. I've got inches, inches, and centimeters. Okay? Let me try that. Let's just do some algebra here. If I had inches times inches on top and centimeters on bottom, I would get some final unit of inches squared per centimeter. That's not a unit that my European friends are going to understand. If I say, I'm 35 inches squared per centimeter, that's how tall I am, they will look at me funny. They will think I'm a little crazy. But now let's look at the other one, inches, centimeters, and inches here. Okay, if I do that, if I go inches times centimeters on top and then put inches on bottom, my inches actually will cancel out, and my answer will be centimeters, that's what I want to tell them. I want to tell them how many centimeters tall I am. That unit makes a lot more sense. So, when you are choosing conversion factors, the first important bit is this guy here, that you know that the top and bottom of your conversion factor will be equal. But the next important bit is that you want to choose the one, here I'm choosing the bottom one, where the units cancel out. So this becomes 70 inches times 2.54 centimeters divided by 1. And when I put that in my calculator, I get 177.8 centimeters tall. Actually, I wrote that in the wrong spot. I meant to put that down here. 177.8 centimeters tall. And I would say that to my European friends, and they would go, "Oh, 177.8 centimeters. That's kind of average." I'm 180, if they were bragging, I guess. That's the idea. I could get a useful answer by converting units. So all unit conversions follow this common principle. And if you're writing it down, start with your measurement. My measurement was I measured myself to be 70 inches. Multiply by a fraction. Take your original unit and place it on the bottom because you want that unit to cancel. Take the unit you want, in this case I wanted to turn it into centimeters, put it on top. And then the numbers on top and bottom should be equal to each other. In this case, I had to look up and say that 1 inch was the same as 2.54 centimeters. And once you've got that set up, take it and multiply it out, and that's your answer. We're going to use this exact same method and the concept of the mole to get molar masses and to be able to use moles in our recipes when we do our chemical formulas and stuff. So, the activity you've been doing has been talking about molar masses and how much atoms weigh. And the very famous scientist Amadeo Avogadro came up with this concept. He was looking at balloons. And he was looking at their ratios of particles to mass. And he found very consistent ratios, and he was able to say that if I fill those balloons up with the same amount of gas particles, then it doesn't matter which gas is in there. They will all go to the same volume. And then he started weighing them. Okay? Now, and getting the mass ratios and things. So if you get the mass ratio for these balloons, let's say you had helium, and you put in there 4 grams of helium. It got to a certain size. Alright? Then you go to the next gas in line. Let's say the next gas in line happened to be neon. If you fill that neon balloon so it is the same size as the helium balloon, it doesn't weigh 4 grams, it weighs 20 grams. And then if you go over to the next balloon in line, and let's say this next gas in line is argon, and you fill it up to the same size as the helium and the neon balloons, you will have a 40-gram balloon of argon. Now, this is consistent with what we see on the periodic table of elements. If you go to helium and look at it, it says 4 grams in the mass of helium and 20 grams with neon and 40 grams of argon. Okay, these are all talking about the same number of particles. And even with stuff that's not gases, we're still talking about the same number of particles have that mass. And we're going to call that number of particles 1 mole. Okay, it's just a way of counting up particles. And in this case, 1 mole is a lot of particles. It takes a lot of particles of helium to get 4 grams. It takes a lot of particles of argon to get 40 grams. The number of particles? Well, the number of particles in a mole is this. 6 0.022 times 10 to the 23rd particles. I'm going to put a little dot there because I ran out of space. So a mole is a very, very large amount of particles. We will call these guys here, these are going to be known as molar masses. The mass of 1 mole of particles. And we'll use it to do some converting. So for instance, I can say for helium, I can definitely say that 4 grams of helium equals 1 mole of helium. Okay, I took the E off because we abbreviate mole when we write it down, or at least a lot of chemists do. That's our equal sign right there. Now, let me make up a situation. I'm going to make up a situation with a balloon where I've put some helium gas inside, and I weigh that balloon, and I get 20 grams. That balloon weighs 20 grams with the helium. We'll say that the helium part weighs 20 grams. The latex part of the balloon doesn't matter. So we have 20 grams of helium inside this balloon. And I asked myself, I say, self, how many moles of helium is that inside that balloon? So essentially I'm asking myself to convert grams into moles. We can do that. 20 is what I measured. I measured that I had put 20 grams of helium into the balloon. And when I do converting, I start with the measurement, and then I multiply by a fraction. Now what I want to get rid of, I want to get rid of grams. Grams of helium specifically, that's what I started with. So I'm going to put that unit on the bottom, grams of helium. I asked myself, well, how many moles that was, so that's the unit I want. I want moles of helium, and I'm going to put that on top. Then I need numbers, and those numbers have to be equal to each other in my fraction. So let's go up to the equal part. Here is what I had. I knew, because of the periodic table, I knew there were 4 grams of helium equal to 1 mole of helium. So, if I come back down here, I can say there are 4, whoops, I put that in the wrong spot. There were 4 grams of helium for every 1 mole of helium. And now, I've got everything in the right place. My grams of helium will cancel. I will multiply 20 times 1, and I will divide by 4. 20 times 1 is 20, divided by 4 should be 5. So I should wind up with 5 moles of helium as my answer. So that's a way for us to convert back and forth. Now, if I wanted to know how many particles that was, I could do that too and say, hey, how many particles are there in those 5 moles of helium? I could do that. Well, now I know 5 moles of helium. Let me put that here. 5 moles of helium. And I know I'm converting. I want to convert to particles. So I'm going to multiply here, and I'll have a fraction. I know I started with moles of helium, so I'm going to get rid of them. Moles of helium. And I want particles. So I'm going to do particles up here. Particles, I'll put a little dot there. Particles of helium. But I need the top and bottom to be equal. I need a conversion factor. So let me go look. Where did I have? Ah, there it is. 1 mole is the same as 6.022 times 10 to the 23rd particles. So I can use that here. I can say that 1 mole is equal to, and I need some space for this, 6.022 times 10 to the 23rd. And I can multiply that out. Well, 5 times 6 is going to be 30, so it's going to be 30, oh gosh, 5 times 22, 110? So 30.11, yeah. And then keep the tens, times 10 to the, 23rd. Now I ran out of space here. Now, that's not a perfect scientific notation number until I move the decimal over 1. So this would actually be 3.011 times 10 to the 24th particles of helium. So we now have a very powerful thing. We can count up atoms, essentially, if we know their molar masses. And the molar masses are always going to be listed on the periodic table. And if we use conversion factors, okay, we can change grams into moles or moles back into grams, or we can change into particles and things, which is useful to us because our balances, let's say you want to weigh out, let's say your recipe calls for 4 moles of sulfur. Okay, that's what you need to react in order to make your reaction go. And you go over to your balance. Here's your balance. Okay, it's got a little round part there. 3 beams coming off of it. Okay, you're going to put your sulfur in a dish right there and weigh it out. You need to weigh out 4 moles. Your balance doesn't read in moles. It says grams on it. So you're not going to be able to use your balance to find moles. You're going to have a gram recipe first. So in order for you to do this, you're going to have to change your 4 moles of sulfur into grams of sulfur. Well, you can do that now. You now can say, I need 4 moles of sulfur. Let's see what that is. 4 moles of sulfur. I know I'm going to multiply. I know I'm going to have a line there. And I know I'm going to have to put moles of sulfur on the bottom because I got to get rid of them, because that's what I started with. But I know I'm trying to get grams because my balance measures grams. So I'm going to say I want grams of sulfur instead. Well, let's look at the periodic table. If I look at the periodic table, underneath sulfur, his mass says 32. And I know the periodic table is telling me that's 1 mole of something. Okay, so that's key. The periodic table will only ever give you 1 mole. Right? Those masses listed on the periodic table are for 1 mole of a substance. So I have 4 moles of sulfur times 32 grams of sulfur divided by 1 mole. And that should give me, if my moles of sulfur cancel, and they do, 4 times 32, which is 128 grams of sulfur. So when I go to my balance now, right up here, I need to put enough sulfur in there until the balance reads out 128 grams. And then I will have enough for my recipe. We're going to use this a lot. This is one of the key cornerstone concepts of chemistry. So super important. And just to reiterate, we start with your measurement. We multiply by our fraction. Our units have to cancel, so we put the right units on the bottom to get rid of what we started with. And as long as the top and bottom numbers are equal, in this case 1 mole of sulfur is equal to 32 grams of sulfur, we will get an answer that is useful to us.